Namaste. Today in this video we are going to discuss about logic. Okay, logic is basically known as the knowledge or technique to solve the problem. Okay, and logic can be classified into propositional logic and predicate logic in terms of AI. Okay, so let us write the note. So logic, okay, logic can be propositional and predicate. Okay, so predicate logic. Okay, and propositional logic is a statement of facts and they are assigned with symbolic variable to represent whose truth value may be determined. Okay, that means propositional logic are those logic which defines the truth value for the statement. Okay, propositional logic. So let us understand proposition. Proposition are those statement, okay, whose value is either true or false but not both. Just as example, 5 is greater than 3, it is true. Yes, she is running. Okay, the statement may be true or false but not both. So these type of statement are known as proposition and they are connected by using connectives. Okay, such as example, or. Okay, P is or and not, implication and double implication. Okay, just example, 5 is greater than 3 or 6 is less than 3. So 5 is greater than 3 is true or 6 is less than 3 is false. So true or false is true. We know about the OR gate. Yes, similarly for AND, not, implication, P implies Q, where P is hypothesis and Q is conclusion. Okay, so the limitation of propositional logic is it can only represent the knowledge as complete sentence and cannot analyze internal structure of a sentence, as well as there are absence of quantifier. So let us consider an example and compare it. X is greater than 5. For this type of statement, the propositional logic does not work because it does not determine what the value of X. So propositional logic fails in this type of statement and cannot deal with variable. So a new logic is developed, that is predicate logic, and in predicate logic it is written as P of X where X is greater than 5. So this is known as propositional function and this is statement, and this whole is known as predicate logic. Okay, so now when X equals to 1, it becomes P of 1 is greater than 5. Now when we put the value of X in this, then it changes into proposition. So the process of putting value of X is known as instantiation and 1 is instant, and when the predicate is instantiated, it is converted into proposition. So 1 is greater than 5, it is false. Yes, so propositional logic is weaker than predicate logic. Okay, because it also does not deals with variable, and when we instantiate the predicate logic, it is converted into proposition. So predicate logic is stronger than propositional logic. Okay, so let us discuss about some more tautology. Okay. Tautology. Tautology is the condition of a statement whose truth value is always true. Okay, for the given combination of each variable of a given domain. Just as example, not A or A. If we construct a truth table of this statement, then the truth value is always true. So let us see A, true, false. Okay, only one combination. Not A is false, true. So not A or A. True or false is true. False or true is true. Yes. So the outcome is always true. So this type of statement is known as tautology. Okay. Similarly, example, not P or Q. Sorry, P. Okay. This type of statement is always true. So next one is contradiction. By word it says, yes, contradiction is the condition of the statement whose truth value is always false for combination of each variable of a given domain. Just example, not A and A. So A, not A true, false. Yes, not A is false, true. So A and not A. True and false is false. False and true is false. Because for AND condition, if all input are true, then only output is true. So here the output all are false. So it is contradiction. Similarly, the last one is contingency. Okay. So contingency is the condition of statement whose truth value is combination of true and false for each variable a given domain. Just an example, A or B. So A, B. Since there are two variables, there will be for combination false, false, that is 0, 0, 0, 1, 1, 0 and 1, 1. Yes. So A or B. False, 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 true, 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 false, true, 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 true. So this outcome consists of false and true. Yes, so it consists both. So this statement is contingency statement. Now let us move to the predicate calculus. Okay. So predicate calculus, it is an example of propositional logic which allows structure of facts and sentence to be defined and expressed. Just as example, Ram is a boy. So it can be written as boy Ram. Okay, the dot is written at the end. It is called predicate calculus, and this whole is known as clause. Okay, a single clause. Ram is a boy is represented by boy Ram. Predicate calculus also helps to express the relationship of substatement units and provides the mechanism for providing statement that can be used as logic representation power. Okay, so it uses quantifier also. So let us discuss about quantifier. So predicate calculus are expressed by using quantifier. So quantifier are used for statement which express the expression as some objects or all objects within given domain. And there are two types of quantifier. They are universal quantifier and existential quantifier. For all or for every, there exists or for some or someone. Okay, so these are the two types of quantifier which we use in predicate logic as well as in propositional calculus. Predicate calculus. So let us define the universal quantifier. So universal quantifier, its symbol is this, and it is read as for all, for every, okay, and it is valid only if all the variables in a given domain are true. Just example, p1 and p2 and dot 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 and pn. If this all are true, then output is true. That means for all predicate or variable, it must be true. Okay, just example, let us consider an example. For all x, x plus x is equals to 2x. Yes, so every value of x, this statement is true. For all x, this statement is true. Similarly, the second one is existential quantifier, and it is symbolized as this, okay, and reads as for some or there exists, and it is valid if one of the condition is true, or if one of the value of the variable is true. That means p1 or p2 or p3 or p4 or pn. That means at least one value must be true for the given domain. And let us consider an example. There exists x plus x, okay, x plus y equals to 3x. For all x, and so there exists x, okay, let us write x and x square. Okay, there exists some x where x is x plus x equals to x square. There exists some value of x, that means some value of x that is true for this statement. Okay, there exists some x which is true for this statement, but not for all. Okay, it was for all, so 2 plus 2 equals to 2 into 2 is 4, 3 plus 3 is 2 into 3 is 6. So for all x it was true. So for all, there exists some x which is true for this statement. 2 plus 2 equals to 2 square, 4, yes, equal, but 3 it becomes 9, it gives 6. So there exists some x only. So this is existential quantifier. Okay, so in next video we will be discussing about first order predicate logic, that is FOPL. Thank you and bye bye.